Okay, YouTube, this is my first in a module of videos that I'm doing on finding function combinations. And that is to say that we're very, very familiar with adding, subtracting, multiplying, and dividing real numbers. But in this series of videos, what we're going to explore is what happens when we take all of the y values from one function and add it to all the y values of another function. Or maybe we take all the y values of an initial function and subtract it. Or maybe we multiply these things together, or we divide these things together, but we can actually do what we do with real numbers with functions as well, since they represent some output number. So if that's our goal, what we're going to do in this video is we're actually going to explore graphing the sum of two functions here in this particular video. So what we're going to look at here is this. It says use the graphs of f and g to sketch the graph of f plus g and explain our steps. So when we talk about the graphs of f and g, I want you to start with this here. Our green graph is the graph of f of x. So f of x looks like our parabola here. Looks like it just got shifted left one from the origin. It maybe has a little bit wider a value, but it got shifted left one from the origin is this green graph. Our g function is this red graph right here. But when we talk about f plus g, what we're really saying is f of x plus g of x. And so when we say f of x plus g of x, what we're really saying is this. Let's take all of the y values on this graph at that particular x value and add it to the y value of the other graph at that particular x value, and you would get some new y value on this new graph that's at that particular x value. So reading through this, it says, choosing a point on the graph of g, use a compass or a ruler to measure its distance above or below the x-axis. So in other words, with g here, we could measure how far above or below the x-axis it is, but what we're really doing is we're finding its y value. So in this particular case, it looks like at this x value here, it looks like an x value of 3 if we're going by 2's, looks like it's at a height of 2. So this is the point 3, 2, but the point is that it's 2 off the ground. Now, it says here, if above, add that distance to the y coordinate of the point with the same x coordinate on the graph of f. That's a long way of saying to take this distance here and add it to the y distance on our graph of f, which is this distance here I kind of drew off to the side. So in other words, what we're doing is we're saying at this particular x value, let's take the y value, or the distance it is above the y-axis here, and add it to the distance that the other graph is above the y-axis there, those two y values, add those together, and you would get some. Let me switch back over to red here. If I were to transport this red distance up to here, you could see you'd get a total distance of this far. And so that being said, you can see how that new point is on this blue graph, and this new graph, in blue, is this graph of f of x plus g of x. So let's check out a few of the other x values here. Let's say at this x value here, -6, we'd say if we take the y value on our green graph, which is at a height of 4, and we add that to the y value at that x value on the red graph, which this looks like it's at a height of like -7 maybe. If we were to add a -7 plus a +4, those would add up to be -3. So the height of our addition of these two things would be this height -3, because that would be the sum of the two y values of that x value. So basically, in order to add two graphs, I guess graphically, what we're going to do is we're going to add the y values of the original graph together to get the new y value of the sum of those two graphs. So let's take a look at this example that I have here. It says sketch f of x plus g of x for the following graphs. This one will look a little bit cleaner because we don't already have the sum of these two graphs on there, but you can see clearly that our green graph is f of x and our red graph is g of x, and we have a linear and a quadratic. So number 2 here asks us, it says how can we use the graphs of the two functions to sketch the graph of an arithmetic combination of the two functions? In other words, how can we use these graphs of these two functions to sketch f of x plus g of x, which is what we want to sketch, y equals f of x plus g of x? And really the answer to this is we are going to add the y values together. Let's put it this way. Add the y values of each graph together at each individual x value. Each individual x value. So essentially what we're going to do is this. As we crawl across here, we say, how about we start at an x value of 0? At an x value of 0, I'll put this imaginary line through here. You can see how this graph here looks like it's at a height of 1, and this graph here looks like it's at a height of -1. So if that's the case, what we're going to do is we're going to add this height of this original graph, +1, to the height of the other graph, -1, and what you get is a new point, 0. So looking at now an x value of 1, which kind of goes through right here, you notice that both graphs are at a height of 0. So if we were to add 0 plus 0, we would get 0, looks like, okay? So what if we go to an x value of 2? So it looks like our green graph is at a height of this. Our red graph is at a height of 1. So if we were to add 0 plus 1, we would get 1. If we were to go over to an x value of 3 now, you can see how this red graph is at about a height, let's put this in red, a height of 2. This white or green graph, excuse me, is at about a height of, I would say, maybe a half. So if we were to add a half plus 2, we would get 2.5, which would be just a little bit above here. Let's pick out a few more. If we were to add the x value, the y value is at an x value of 4. So this y value plus this y value, that'd be like a y value of 1 plus a y value of 3 would be some new y value at 4. So that would be like right here. So now I'm going to go back a little ways. How about we go to -2 here? If we were to add a height, let's go red again, a height of +4 on this graph to a height of -3 here, that would be 4 plus a -3 would be a height of 1 on the new sum graph. And then let's go to -4. -4 looks like it's at a height of about, I'd say, 9. And at -4 on this graph, it looks like it's at a height of -5. So a -5 plus a +9 would be a 4. So a -4, the sum of these two graphs would be here. You can see how what we're getting is the new sum of these two graphs, which looks like this parabola really got kind of shifted to the left from our original green graph here, or maybe down if you want to interpret it that way. So we'd say that these are the two graphs initially, but this is the sum of the two graphs there. And so what I want to do for letter B here is the exact same thing. Let's just pick on a few set x values. So again, at -4, we'd say that this graph here, g of x, is at a height of about 5. This graph here down here is at a height of about -9. -9 plus a +5 would be a -4. So the sum of those two would be at -4 here. If we were to go to -2 as an x value, we'd say this graph's at a height of about 3. Okay, this graph's at a height of about -4. So when you add those together, -4 and a +3 gives us a -1. So -1 would be about right here. Okay, if we were to go to 0, this one's at a height of 1, this one's at a height of -1, so their height added together is 0. If we were to go to 2 here, this one's at a height of 0. This one's at a height of -1, and 0 plus -1 is -1. And then one more here at 4. If we were to add a height of -1 to a height of -3, we would get a total height of -4. And again, you can see how we get this combination of functions right here that comes out to be this. So when it comes down to combining two functions in terms of addition, really all we're doing is adding the y values together for the two graphs at every individual x value. Cheers.